Hello everyone. Hello Nitin. Hello Dheeraj. Hello Pratmesh. Hello everyone. So welcome to the last day of the TRIE Bootcamp. Today we will see some unobvious applications of tries. Like when we introduced tries, we kind of introduced it as an application of strings, right? Like it somehow has to do something with strings. But there can be some cases where try help us in solving problems which have no relation with strings, and we'll try to see, we'll try to solve them. See, data structure and algorithm is all about doing as many patterns as you can and doing them well. So let me correct myself, it's not about doing as many patterns as you can, it's about doing as useful patterns as you can and doing them very well. So we have seen, okay, after the end of the boot camp you'll be like, okay, I have done certain problems and I'm getting confused. But when you will dive deeper into the methodology that we chose to solve the problems, was we essentially tackled only one pattern till now, and it was how do we create a string and represent it as a trie data structure. What is a trie? A prefix tree. So essentially we have just done in these three days, we have just mastered that one pattern. Yesterday we just did a new modification, like a modified way of that pattern, in which we kind of use some knowledge of graph. We use DFS on the trie structure. We can apply that because we saw that it's kind of a tree, right? So now today we will be jumping on to the next pattern, which involves tries in bits. Using try in problems of bit manipulation, or which involve like XOR or AND, right? So try to break this down whenever bootcamp finishes. Try to think about these things. Like, okay, I'm getting confused, but essentially we just did just two patterns, right? One pattern involves strings, and now we will tackle second pattern, which will be, we will be solving problems uh, which kind of enlighten us that try is not only used on strings, it can be used on bit manipulation as well. So whenever in future, whether it's a OA of a company or you're just solving contests, you will know, if you are sitting today with all your focus, then you will somehow remember, okay, that day in DevTown bootcamp we did a problem where try was used in bit manipulation as well. So you will try to think in that direction at least for 5 minutes, and maybe that, who knows if that problem will help you in solving it. Who knows if that approach will help you in solving that problem, right? So today we'll today we'll try to solve another problem. Before that, let me just share my screen. Yes, good evening everyone. So today, let me just recap for the people who just joined. Today we'll be introducing ourselves to how try can be used on problems which include bits. Okay, like which include some manner of bit manipulation or representing bits as a try. For now, just a second. Hello, Arif. Hello. Just a second. Yes, fine. Okay, now can begin. Okay, so what I'm asking was like, do anyone have any doubt? Does anyone have any doubt in this problem? Design and add and search in our dictionary, like where we kind of did a DFS type of stuff. Does anyone have any doubt in this? If you have, then you can uh, tell me right now. We will like whether you have doubt in the terms of coding this approach. How did we code this approach? Whether you have doubt in how did we come up with this approach? Any kind of doubt, because this is the last problem which in which we represented a string in a trie. Now we will kind of replace this string. We'll be using bits as a trie, so will be it'll be easier for me to transition from string to bits if uh, everything is clear till now. Okay, Tirthana says no. Karan says okay. Dheeraj says no. Okay. Okay, Komal got it. I will just wait for just 1 minute. If anyone has any doubt, you can quickly type it in the chat. Okay, got it, Zoe. Otherwise, we'll just move on to the new problem, the next problem of the day, which will be a bit different. Like you will see it and you will be like, how are we applying try on this? But just stay with me. I will explain. Okay, I guess there is no problem to anyone. Okay, Sushmita got it. So this is the new problem. Maximum XOR of two numbers in an array. Okay, this is a test for you guys. Can you guys give me any algorithm which solves this problem? Any algorithm. It should be correct. I'm not putting any constraints right as of now. Constraints you can imagine as low as possible. Just give me an algorithm which is correct. Let's see how sharp you guys are. For now, just forget the constraints. I'm asking for uh, if any algorithm you can think of which solves this problem. Can you think of any algorithm? Greedy algorithm. Which is that greedy algorithm? Can you just type your algorithm in the chat? If anyone comes up with any algorithm, it will be great. Because because then it will be easier for us to understand why we need try in this. It's just the first step. Because when I first solved this problem, uh, I thought of it. Okay, Nitin says bitwise. I mean, it will be easier if you guys can type the basic idea of your algorithm. Okay, yes, Harsh Khandelwal. Harsh says two for loops, brute force. Okay, I get it what you're trying to think. You will just put two for loops, you will pick two numbers, and then you will XOR them, and just store the maximum answer in a global variable, right? Hashing technique. Hmm, okay. Loops, Kushal, yes. Okay, so some of you are kind of able to figure out. Some of you guys are kind of able to figure out. Yes, Vishwaraj, right. So you can use loops in this. I think most of you now get the point. Okay, so yes, Sana, brute force. So brute force can be something like this. Pick two numbers and check their XORs and do this for every pair. Okay, so we know that this can be easily done via two for loops, right? Yeah, Nashikar gets it. Okay, Zoya, you're kind of, yes, you're right. You're kind of giving me the exact optimal solution. Okay, so can anyone give me the time complexity of this approach? Time complexity of this approach? Anyone? Give me the time complexity approach of the brute force approach. Can anyone give me the time complexity? I believe it will be O of n square. Yes, Vishwaraj, it will be O of n square, and space complexity will be O of 1. Yes, every one of you are right. Shreyas, Malik, Kushal, Sarojini, Sana, Isha, Kirthana, everyone is right. Very nice, guys. O of n square and space complexity is O of 1. So can any one of you, can anyone of you guess what will be the optimal solution's time complexity? I think this we can guess, right? Exactly, Renuka, it will be O of n square. Can anyone guess the optimal solutions time complexity? Guess it. We have not discussed it right now, but if we're trying to reduce time complexity, which complexity can we aim for in this problem? It's pretty simple, right? It's not that simple, but just stay with me for a while. Let's say there is an array. Can you comment about maximum XOR of two numbers in an array without seeing the whole array? Can we comment on maximum XOR of two numbers in an array without ever seeing the whole array? This is how I think about when I'm trying to figure out the complexities, because sometimes, like during like lead code, code forces, code chef, you are given constraints, and via constraints you kind of get an idea uh, which time complexity algorithm you should code, but you should think of. But sometimes constraints are not given, like in OS, right? So how do you judge that what should be the right complexity? I judge it in such a way that for this problem, can I comment on maximum XOR without looking at every element, without even looking at every element? Can I do that? Yes, Vedant. These will be the two complexities which we'll be targeting upon. But first, give me the answer of, or first think about it yourself, that can you comment on maximum XOR of two numbers if you have not seen the whole array? Think about this. If there is even one element you have not seen, there might be a case where that element is the X factor, right? Where that element is a complement, exact complement of another number, and is XOR up to become 2 raised to power 32, which is the maximum like int max, right? So exactly, Sana, Vishwaraj, you are right. We cannot comment without seeing the whole array. We can't. So login cannot be used. That's how I kind of think about it. So I at least have to use OFN, and we already ruled out OFN square. So we kind of have to reduce the complexity to OFN. The argument looks quite decent why we have to use OFN. Okay, so one way to one way to solve this problem can be that, let's say we have a root node, right? We can go with a 0 or with the 1. That's how I can how can I simply create a tree structure for two numbers? See, it will be quite simple. Just stay with me for a while. Like what did we do in the case of this was a root, and now we used to go to every alphabet, right? A, B, C, D. Not every. Some of them will be null. Those is right. We used to do this. Now in this case, this will be our root. This will be our 0. This will be our 1. Right. And again there will be some 0 or 1s here. Right. Okay. So I believe that you guys are kind of getting how we are going to create tree out of this number. Right. For example, if I have a number which is 9, it can be written as 1001. I can simply create a tree, right? 1001. This is a simple tree, chain like structure. Exactly. That's how you should progress in thinking while contest or while solving this problem, that okay, O of n doesn't work. So maybe I should think of an efficient way how I can store my bits, because the information of bits is perfectly sufficient, right, to get to that number. Let's just think about it. How can we represent these two numbers, 1001, 1011, and 1002? Sorry, sorry, 1000. Okay, and let's say I have a number as, like, I'm writing the representations here. This will be 2, this will be 9, this will be 8, and this will be 11. Right? So let's say I have an array 2, 8, 9, 11. How I'm going to create a trie structure? Because this will be my root. We're having a 0 and a 1. 1 will be again be having a 0, and this will be having a 0 and a 1. Right? This creates a tree node, right? Trie structure, right? Because see, we have covered almost all. These is these are 2, these are 8, this is 9, and this is 11. Can you guys feel it that this is 2? Can you guys understand why this is 11? Like, can you understand why this is 8? Exactly, 10 is common. Yeah, I think yes, Dheeraj, you are understanding. Great, great, Kirtana, great. So I think you guys are able to understand how we are representing numbers, right? Okay. So now I just need to check for every number. Just give me a second. Yeah, that's great. So, and we are given that int less than equal to 10 raised power 5. So, for being on the safe side, we can just store 32 bits. So, like we can, like, I hope you guys are able to understand that we can just add some, what, this is a 4-bit number as of now. This is a 4-bit number as of now. We can add 28 zeros to create it, 31-bit, 32-bit number, right? So we can store every number in the form of 32-bit number. Okay, 32-bit. Uh, okay, Jay. Okay, I hope you are understanding what we are doing right now. So we can store everything in a 32-bit number because constraints allow us to do so. Okay, so now look, now see closely. We can simply take a number. Let's say we have a number. We have like number. We take one bit and we see if we have the complement of that bit in this level. Do we have the complement? Yes, we do. Then we add that number. Let's say it's 31st bit. Let's say I have a number like this, which is 32 bits. Okay. Okay, Raj, nice. Okay, so let's just say that, say I have a 32-bit number. Now see, in order to add this bit in my maximum answer, what can I do? I need to find what I need. I need to find a number such that this complement is present. And if I can find that number, can I say that I should surely need this number? I would surely need this number. Or no, no, I can't say that, but let's think like this. If I can find a complement of this number, I can surely say now my search space reduces to the numbers which have this bit set, right? I will only search from those numbers. Can you guys understand this? That I'm searching from the most significant bit and the complement of that bit. In this case, it's 0. I will search for 1. I will search for the numbers which have their 31st bit as 1. Search for those numbers. And I only search with these numbers now. Why? Because we know that the fact that this bit is now set in one number and unset in one number, the truth table of XOR will give us a set bit. And which set bit it is? The biggest set bit, right? And we know that this is like greedily we should take this because the sum of these is less than this. So even if we manage to get all of them set, all of these bits set, we still can't account for this. So if we get this set, we should take that possibility. If we are able to set this bit by taking a number, we should take this possibility, right? Take that possibility. Right? Are you guys able to get me? Like, think about this. Let's just say we are trying to see we are trying to see we are just considering 4-bit numbers, trying to see which gets the maximum XOR with the 0. And what possibilities we have? We have a possibility of 100, we have a possibility of 0011. Can you now understand that we will obviously XOR with this, because this will result into 1000 and this will result into 0111. This is 8, sorry, this is 7 and this is 8, and it's bigger, right? So can you see, greedily we should start from the biggest bit, like 31st bit in our case. And if we find the complement, then just go in that direction. You don't really need to care about the other direction. Like in this case, if we are going with 000, seeing which is the maximum XOR with 000, we will simply go with 1. We found the complement. We don't really need to care about this branch. And if we don't really find the complement, then we will go with the same bit, right? Then there is no option. Yeah, I think Praveen gets it. Okay, I think everyone should get it, right? Everyone be responsive, because this is important. We are learning a new pattern today. We are not just solving the same pattern like yesterday. Now think about this. How will my node structure change? How will my node structure change? My node structure will simply change to link star links 2. I just need 2 space, right? First I needed to check for A, B, C, D, E, F, G, H till Z. Now I just need 0 and 1. I hope it's clear to everyone. Hope it's clear. Great. And think about this. Now do we need a flag? Do we need a flag? We are saying that we will always keep the height of the tree as 31, 32. So do we really need to care if the number ends or not? Or do we trivially understand that the number has ended? Is there a need of flag, bool flag now? Just give me a boolean answer in the chat. Is there a need of a bool flag? Like a flag, sorry. Is there a need of a flag in this case? In the case of bits? In the case of bits, we are keeping the height of the tree as constant. The tree height is constant, is 32 bits. Do we really need a flag? What was the need of the flag? The need of the flag was, in the string case, tell us if the word has ended or not, because in that case, word can be like 10 raised power 9 length, or even just a single character word. But in our case, we have converted every number into a 32-bit number, and then we are adding it into a trie. Every number is converted into a 32-bit number, and then we are inserting it into a trie. So we know that in order to traverse a complete number, we need to go down 32 depth. So now those guys who were saying yes, like Himanshi, Raj, Vishwaraj, do you guys understand? We don't really need flag in this case. Exactly, Vishwaraj. If we are converting into 32-bit, there is no case. There is no need. And we will obviously need to convert into 32-bit. Why? Because our algorithm wants us to go to the most significant bit first. So we need every number to be normalized into 32-bit so that we can check the 32nd bit is 31st bit easily, 32nd bit, or I'm just alternating between zeros indexing and first indexing. There are 32 bits, don't worry about that. I'm saying 31st bit because I'm like considering zeroth indexing, zero base indexing. Exactly, because the height is same for all numbers, right? So this is our node structure, simple as that. This is our node structure. So let's try and great, Raj, great. Don't take away any doubt from this session. This is a very important, very interesting concept. We are incorporating tries into our stuff. And just those of you who want attendance, just uh, you can just wait for a second, or you may leave and come back after 10 minutes. So try. What will we need in a try? Right. Now what do we need? We obviously need a insert functionality. And what will the insert functionality need? It will just need a number. We will need another functionality which will be get maximum. And it will also contain a num, an integer, because we are keeping one thing. We are going with a for loop. What we are doing, we are going on a for loop for, and now for every number we are checking how much maximum XOR can we get if this number num of I, if we take this number as the first number, we fix that number, and now we search what the maximum XOR we can get. And what's the strategy we are doing? We're just flipping every bit. If it's 1, we are going for searching for 0. If it's 0, we're searching for 1. 0, searching for 1. Right? This gives the maximum XOR, right? Great. So now we can like start to code it up. Just give me a second. Not exactly hertz. Maximum and minimum numbers, or not always gives you not always gives you the optimal answer. Attendance is in the chat, and please mark it. Attendance is in the chat. I mean, I will explain you why. Harsh, I can just give you a counter example. I guess that will be enough. Like, till everyone else is marking attendance, I can like, just see this representation. The representation can be 1, 1, 6, 9, 15. Okay. And now if we convert it into binaries, be 0, 0, 1, 0, 1, 1, 0, 1, 0, 0, 1, 1, 1, 1, 1. If we go with your method, what will Harsh do? Harsh will take 1, 1, 1, 0, 0, 0, 1, XOR them, and it will be 1, 1, 1, 0. So his answer will be 14, right? But optimal way to do this is to take 1, 0, 0, 1, 0, 1, 1, 0, XOR them, and now you get 15. Okay, Harsh? Yeah, great. Okay, so this will be the structure of the solution. Let's try and code this solution and see if we have completely understood this concept, and try to code it with me, right? It will be fun. It will be fun because there will be someone to solve your problem. When you will be solving it alone, then there is internet is the only hope. So right now you can solve it with me, and if you have any problem, you can just ask it in the chat right away. Okay, so let's begin. Oh, actually, I coded some part before. Okay, so as discussed, we need a node class. We will make it public, and we need links to no need of flag. Whenever we declare this tribe, we need to assign a new node to root. Okay, and we also need a insert function, right? So insert function will take a num, and we simply need one way to and we just traverse. Oh, oops. right? Now what do we need to do? We need to check the bit. Okay, so we need to have a function which tells us if it contains the key or not. It's same as the previous function which we coded contains key in bit and simply return link bit not equal to null. Okay, all right, and there should also be a function to put at a bit void put and bit node node star node. Okay, and then we simply need to go to the next bit, next subsequent bit to fetch another bit, right? That will be simply done by this, and for that we need a node star get function. All right, I guess we coded up the solution well. Now we simply need a get max. What will the get max do? Get max just simply iteratively search for the complement of that node, of that bit. Okay, there should be a max which should be equal to 0. And now we simply or the max with the bit. Okay, if we don't found a complement bit, we can simply go to the same bit, right? There is an option. Okay, now we simply declare a try. I think we didn't make everything public. We have, yeah, right. Okay, so we can simply now in first can be to insert all the elements, answer variable. Yes, Sana, you are right. We are moving to the opposite branch. Oops. Yeah, it's accepted. I get it will work on the final test cases as well. Yes, it works. If anyone has any doubt in this code or any implementation part, you can ask in the chat. Obviously, I will share the codes and all after the session. The codes and the notes I will share. Explain the question once again. Okay, explain the question. Okay, so question was this. So this was the question. Maximum XOR of two numbers in an array. So basically, you had to give the maximum XOR. We can find maximum XOR of two numbers in an array. We basically finding the maximum XOR we can do by. Okay, dry run for a small example. I think I did it just right now, but I can do it here as well. Uh, let's do it on this example only. Okay, I have taken 4-bit, but obviously you know that it will not be 4-bit, it will be 8 bits. Sorry, 32 bits, what I'm saying. 0001. This is the tree, right? Oh, okay, sorry. Yeah, this is the tree for this test case. This test case which I used. Right, so just let's just see sequentially. Now for 0001, 000, which is 1, what is the answer? We first search for a 1. There is a 1, right? So we add 8 to the answer. Now we search for another 1. Yep, there is also 1. We add 4 to the answer and we go into that branch. We search if there is another 1, because why we are searching? Because we're taking the complement of the bits. Yes, there is also another 1, so we add 2. For now, for the last bit, we do the complement. It is again 1, and we found another 1. So we add 1, which is equal to 15. Hence, the answer for this is 15. The maximum XOR we can get if one number is fixed as 1 is 15. Now we take another number which is 001. Oops, it is 0. What I'm saying. Now it is 1. Okay. So now check. The complement of the bit is 1. Do we found 1? Yep. So we add 8. Now the complement of the bit is again 1. Do we found 1? Yes. So add 4. Now the complement of the bit is 1. Did we find 1? Yes. So add 2. Now the complement of 1 is 0. Did we find 0? No. We go into the branch but we do not add it. So we simply are adding 0, right? So it's coming out to be 14. Now checking for 0110. Oops, there was no number no that has 00. Why did we check for 0? There is no number as 0, right? My bad, sorry. So now we're checking for 0110. Complement is 1. Did we find 1? Yes. We had 8. Did we find 0? Yes. So we add 4. Complement is 0. Did we find another 0? Yes. We add 2. Now the complement is 1. Did we find 1? Yes. So add 1, which is 15. So if we take our number as 6, we can now get a XOR of 15. Do you guys get it? I hope that I hope that now everything is clear to all. And I hope you guys enjoyed the boot camp. So this was the end of the boot camp. We did a lot of questions. Very nice, Harsh. I think we got we got the maximum answer from 6 only, right? Yeah, I hope you guys enjoyed it. I hope that it was a great learning. We did some problem of tries. Today I was not able to do a lot of problems of bit. I was planning to do 2 problems, but first I guess some time was spent on explaining the idea of bits, right? But that's fine. That's fine. The most problems, if you find a way to how to represent, if you can represent, then you will be able to code. You'll be able to get the idea really quickly. That's fine. Great, great. So here's the end of the session. I'll hopefully meet you in another boot camp whenever it might be. So thank you for attending this 4-day session, 4-day boot camp. Uh, I hope somewhere in an OA or in any contest or anywhere, this boot camp will add some value in your life. Uh, Thank you. Yes, Kirtan, I will share the code. Okay. You guys are getting the code, right? I have shared the date till the codes till day 3 with the team. I hope you guys are getting the codes. I've shared a PDF which contains all the codes till now. So, and I will share another PDF today. So, yeah. Thank you, everyone. Bye bye.